So we're finishing up our unit on polynomials, and I wanted to do a video on these Khan Academy unit tests just to give you somewhat of a study guide so that you might be better prepared perhaps for the assessments that are coming up. So let's take a look at what we've got here. The first, our assessments are going to be broken up into 4 separate parts, and these are the 4 parts that they're going to be broken up into. Let's attack the polynomials arithmetic first. In this video, we'll do each one in separate videos. So there's 9 questions in this unit test, and not all of them will be assessed in our assessment. In fact, I believe the first one that comes up here, the average rate of change, is not something that we are assessing in our unit, but that's okay. It's something we can actually look at anyway, and it's not too difficult to understand because, well, rate of change is something that we're already familiar with. Rate of change is basically just a slope. Remember that the slope m of a linear equation is the change in y over the change in x, or more specifically, y2 minus y1 over x2 minus x1. Well, we can extrapolate this to work as well, okay? H of x is essentially y, your y value for any given point, and each of these is just 2 given points, 2 given x values for points. Okay, so let's check the first one. Let's check A for a second. So if we were to say that this is x2 and this is x1, and by plugging in 4 for here, we'd have y2, and by plugging in 1 for here, we'd have y1. Okay, so let's see how that works. All right, it's probably worthwhile to work out y1 first, y2 and y1 first. So let's try that out. So let's say h of 4 is equal to 4 squared minus 1. Well, that's 16 minus 1, which is 15. And then we go with h of 1. And h of 1 is 1 squared minus 1, which is just 1 minus 1, which is 0. Okay? So what we have here now, if we look at it, is so we've got y2 is actually 0. Y2 is actually 15, sorry. Right? Okay, so it's 15. And y1 is 0. Okay? So let's put it all together. Okay? So y2, which is 15, minus y1, which is 0, over x2, which is 4, minus x1, which is 1. That gives us 15 over 3. Well, is that a negative average rate of change? No, it's not. So that's not what we're looking for. So this is not the one. All right, let's check this one out here. Okay. So it's good to practice this, of course. So let's go with, we've got h, we've already got h of 1, so we're not going to need that again. Let's look for h of negative 3. All right, h of negative 3. So h of negative 3 is equal to negative 3 squared minus 1. And that is, of course, 9 minus 1 is 8. Right? So we now have what we're going to call, this is our x1, so our y1 is 8. Right? So let's go with the rest. So our y2 now is this h of 1, so that's 0. So y2 is 0. y1 y1 is what we just found, that's the 8, so minus 8. And we've got x2, which is 1, and x1, which is negative 3, so minus negative 3. And hopefully you see what's going on here. And we have negative 8 over positive 4, and so that is going to be a negative rate of change, and we can select that one. Okay. Right. So that's how you work out the average rate of change of an interval. We'll have more on intervals in actually the fourth assessment, and this is something that you can then extrapolate from what you learn in the 4th assessment. Say, oh well, now I can actually figure out not just that something is decreasing or increasing, but what the average rate of change of that increase or decrease is, which is kind of useful. So let's move on. All right, this is more like what we're going to see in our in our assessment. So what this is expanding. It's basically using your distribution rules. It's multiplying. This is multiplying polynomials, right? We've got a monomial on the outside. We've got a binomial on the inside. So we have to multiply in here, right? So what we have here is we've got 4b squared times b cubed. Well, 4 and the coefficient here is 1, so that's 4, right? And then b squared times b cubed. Well, to multiply the two variables that have the same, that are the same variable, same base, and different exponents, what you do is you add the exponents. So that's going to be 4b to the power of 5, right? And then the next one here is going to be 4b squared times negative 8. Well, we're going to multiply negative 8 times 4, which is negative 32, and we've no b's to multiply, so that's going to be b squared. So we're looking at a new polynomial right now. We're looking at 4b to the power of 5 minus 32b squared. Okay, so let's take a look at another one. So standard form. So which polynomials are in standard form? Typically what we're asking here when we go to the assessment is we're asking like what is the degree and what is the leading coefficient. Recognize that the degree for our purposes with single variable polynomials is the highest exponent, and the leading coefficient is the coefficient that goes with it. So if we were to look at the second example here, just to look at it, we would isolate this term right here and say, well, that is the highest exponent. That is the highest exponent, and the coefficient that goes with it is the coefficient that goes with it is the leading coefficient. So we would say this has a degree of, I think that was a 2, and it has a leading coefficient of negative 2. Right? Let me clean it up so we can actually see it. Yeah. Degree of 2 and a leading coefficient of negative 2. That's what that one has. And in fact, this is written in standard form. It's got the highest exponent first, and it works its way down on the exponents. There's an exponent of 1 on this t here. We don't see it. There is a t to the power of 0 beside this 4, but we don't see it because t to anything to the power of 0 is equal to 1. So this is certainly, this b here is certainly an option for us. We're asked to choose all that apply. So let's look at this one here as well. This one has the highest exponent first and technically works its way down, but we don't need to see the t to the power of 3 because it has a coefficient of 0. The t to the power of 2 also has a coefficient of 0. The t to the power of 1 has a coefficient of 0. And the t to the power of 0, as you can see, is a coefficient of negative 1. So that would be one for us to choose as well. It is in standard form. This one here is in standard form as well. It's t to the power of 1, t to the power of 0. So highest exponent first, working our way down. Okay. All right, so subtraction. So subtracting polynomials is something that certainly comes up in the assessment that's coming up. So subtract this polynomial from this polynomial, right? So that means this minus this, okay? And typically that's the way it's going to be presented to you. So what we have is we've got 5a squared minus 6a minus 4. That's one polynomial, and we're going to subtract negative 7a squared plus 3a minus 9. So the first step with subtraction, certainly with subtraction, addition doesn't matter quite as much, but with subtraction, the way to look at this is distribute into the parentheses. Distribute this with the second term here, whatever's outside the parentheses here, distributed in. Whether it's actually got a coefficient, a leading coefficient here, or whether the coefficient is 1, as you can see here, just be aware that the sign must go with it. So we're going to distribute this sign into the second polynomial, and we're going to go from there. So let's distribute the sign. So negative 1 times negative 7a is positive 7a squared. Sorry, that was 7a squared. Negative 1 times positive 3a is negative 3a. Negative 1 times negative 9 is positive 9, and then we can write the whole polynomial all as 1 and then combine like terms. So we've got 5a squared minus 6a minus 4. You notice there's no leading coefficient here, so nothing to distribute. And this is what we got going on here. Okay, let's look at combining like terms. Okay, this term here, first term and the fourth term are like terms, so we're going to combine those together. So 5a squared plus 7a squared is 12a squared. Okay, this second term here is a negative 6a, and we see a negative 3a here. So negative 6a plus negative 3a is negative 9a. So we've got negative 9a. And then we have a third term here, negative 4 and positive 9. So negative 4 plus 9 is going to be positive 5. And that's how you do subtracting polynomials. It's the same way as doing adding polynomials, in fact. But it's obviously you just have to be very careful with that negative in your second term. So we're looking at 12a squared minus 9a plus 5. Okay, moving on, we're looking at multiplying polynomials now here. As you might recall, that areas are based on, areas are calculated with multiplication, base times height. In this case here, we've got like 3 rectangles, and each rectangle is given as a base times height. So we've got a 7a times 4, times 8, sorry, 7a squared times a to the 4th, 7a squared times 5a squared, 7a squared times 4. All right, so that's what we've got going on in this rectangle. This rectangle basically has a length of a to the 4 plus 5a squared plus 4. So this is a really good visual interpretation of what distribution looks like. Let's take a look at that in terms of what it would look like if we wrote it as a mathematical problem. So if we wrote it as a multiplication of polynomials, so we've got 7a squared would be our coefficient of the polynomial, a to the 4 plus 5a squared plus 4. All right, so that's what we're looking at here. It's the same thing. All we're doing is multiplying. It's a good way of actually visualizing that this is, you know, that an area is a multiplication as well. So 7a squared times a to the 4, that's going to be 7a to the 6. 7a squared times 5a squared is, so that's plus 35a to the 4. 2 plus 2 is 4, right? And then 7a squared times 4 is 28a squared, and that's what we're looking at right here. So the whole area of this larger rectangle of all 3 colors is this polynomial 7a to the power of 6 plus 35a to the 4th plus 28a squared. All right, so that's another multiplication problem for you. Just looking at it from the perspective of area in a different way. Okay, so we've got 2 monomials here, and you can see it's again written in it's a multiplication form, right? We just have to multiply them, and we need to write the monomial in standard form as well. So just watch out what happens right there. So we're looking at what we're looking at here is we multiply the coefficients together. That's going to give us negative 3 times negative 2 is going to give us positive 6. And then we multiply the variables together. So m to the 5 times m to the 4 is m to the 9. Right? So that was a little bit simpler than the last one. It's kind of, as you can see, in these Khan Academy assessments or quizzes or whatever they are, they jumble up the order of the problem sets within the unit. So sometimes you get the easier ones halfway through, which is kind of nice. It's always nice to kind of break up an assessment and have something that's easier halfway through. Okay, so this is another multiplication problem. It's a recognition, first of all, that a square on the outside is multiplying the whole polynomial times itself. So we're multiplying it times itself twice. So we're looking at 6y squared plus 5y to the fourth times 6y squared plus 5y to the fourth. Right, so now we need to employ our FOIL method, right? So the FOIL method we saw with quadratics. So the first, the outside, the inside, and the last. So look at this. The first terms, the outside terms, the inside terms, and the last terms, right? So the FOIL method. Let's do the first terms first. So 6y squared times 6y squared. So 6 times 6 is 36. Y squared times y squared is y to the fourth. Right, outside terms, right, is 6y squared times 5y to the fourth. So that's going to be 6 times 6 is 30. And y squared times y to the fourth is y to the 6. Okay. All right. Next one. So that's first outside. Inside. Inside is 5y to the fourth times 6y squared. So this 5 times 6 is 30. So plus 30. And y to the fourth times y squared is y to the 6. Right? And then we've got the last terms, 5y to the fourth times 5y to the fourth is 25y to the 8th power. Okay, so you might kind of expect this, right, because we're squaring the terms, right? Let's combine like terms right here in the middle. You're always good. It's twice always the middle when we're looking at quadratics here, and we get 36y to the fourth plus 60y to the sixth plus 25y to the eighth. Now, let's write this in standard form when we put it in because, well, we don't want Khan Academy to kind of tell us that it's wrong because they might say, well, no, that's not in standard form, so let's do that. So that's going to be 25y to the 8th plus 60y to the 6th plus 36y to the 4th. So that's what we got going on there. So let's plug that in there. All right, so your previous stuff that you learned, that you learned in quadratics still applies here, right? 60y to the 6th plus 36y to the 4th. And hopefully I haven't made any calculation errors yet, which is great. Every so often I make a calculation error, and I'd like to say it ruins a video, but it doesn't. All right. So here, look at this one here. This is a difference of squares right here, and we'll see that the what's going to happen is the middle of this is going to cancel out. But I want to do it in longhand. I want to do it in FOIL for you, so you see what's happening. Kind of just a good time to refresh what's going on here. But it's a difference of squares, and you'll see what goes on with the squares that come out of it in the polynomial. So FOIL again, 8 times 8 is 64, right? As you might imagine, you're going to square these first terms, right? We're going to square the last terms as well. You'll see what happens there. We've got negative n to the 7 times 8. No, let's do it the right way first. Let's do the outside terms. So you got positive 7 times n, positive 8 times n to the 7. So we've got plus 8n to the 7. And then on the other side, we've got negative n to the 7 times 8, which of course is minus 8n to the 7. You'll see that those two will cancel out, right? And now we've got negative n to the 7 times positive n to the 7. Well, that's going to be a negative n to the 14, right? So squaring those two gets you 14. Gets you a power of 14, right? So you see what's going on here. These two middle terms cancel out when you combine like terms, and you actually get 64 minus n to the 14. And in standard form, of course, that would be reversed in order. That would be n to the 14. Sorry, negative n to the 14. Be careful with that sign. It belongs with the term. plus 64. But I would imagine that Khan Academy is going to accept both ways. It's not telling you to write it in standard form. I'm just writing it in standard form because that's kind of more proper, right? You can see your leading coefficient in this polynomial is 1, and I want you to get used to that, okay? But you won't be penalized if you put it in like 64 minus n to the 14. Unless, of course, it tells you to write it in standard form, which is kind of why I'm doing that. Okay, one last question, and you should be ready for our summative that's coming up on polynomial arithmetic. All right, so polynomial arithmetic is going to cover addition, subtraction, and multiplication of polynomials, and this is one last multiplication problem for you. Okay, so what we're going to do here, this is a little bit more complex. Remember that what you're doing is you're multiplying every term in each polynomial times every term in the other polynomial. So it's kind of like FOIL, only with an extra piece to it. Okay, I like kind of doing this in opposite order. I like putting the smallest one first, right? So I'm going to do that, and it's okay. You can do this. You can write this in opposite order. So q squared minus 5, right, times q squared minus 2q plus 5. I do that. I like that because I like kind of going, okay, I start with this q and I work my way in 3 times. Then I start with a negative 5 and I work my way in 3 times. In my head, it seems more. It seems like I'm doing less, but it's actually I'm doing the same amount as if I started here and just went in twice, and went in twice, right? Okay, so I'm distributing in each term. So the q squared times q squared is going to give me q to the power of 4. Q squared times, so I'll make these arcs so you see it. Q squared times negative 2q is negative 2q to the power of 3. And q squared times 5 is positive 5q squared. Okay. All right, let's move on to the negative 5. Negative 5 times q squared is negative 5. Negative 5 q squared, and we'll see that those two cancel out neatly. We'll do that in a second. Negative 5 times negative q is negative 10q. And then negative 5 times positive 5 is negative, hang on, I messed a sign there. Negative 5 times negative 2q is positive 10q, right? And negative 5 times positive 5 is negative 25. Right? So let's combine like terms. It looks like the only terms we need to combine are these two right here. So we have q to the 4 minus 2q to the 3rd. These cancel each other out, so we're going with plus 10q minus 25. You can kind of see there that there's a 0q squared kind of tucked in there that we don't see because it's not necessary. All right, so there you have it. We've got q to the power of 4 minus 2q to the power of 3. And stick around because I've got something else I just want to show you just before we finish. Plus 10q and then minus 25. Okay, so I've got something I want to show you here, especially if you're using this unit test as a study guide, right, or as a study resource, right? I'm going to clear that so we see it and take a look at what happens next, right? So you show your summary. Show your summary right here, okay? And it's going to give you a summary of your skill changes. Now we can see right here that everything is leveled up to pretty much the top level because we got every question right. But when you scroll down through here afterwards, you will see anything that doesn't have a double bar in it, or well, even a single bar might count, right? But anything especially that has no color in it at all, right? That is just grayed out. That is an area that you should practice before doing the summative because that's an area that you definitely don't understand according to the test, okay? So this is a very good resource just to see if you're ready for the summative. And good luck with that, and we'll catch up later. If you've got any questions or comments, please leave them below, and I will be sure to get back to you.